All right. So thank you everyone again for joining us today. We're going to hear now from Cameron Bielstein, who is a software engineer 3 in the Allen Institute for Brain Science. And he has associate's, bachelor's, and master's degrees in computer science. So Cameron, to get us started, can you talk about your science journey from high school to now?
I can, and before I get going, can you hear me okay? Okay,
Yes.
great. Um, yeah, so high school to now science journey. So mine's a little different in that I am by training and in practice an engineer more than a scientist. Um, and so I kind of go more through an industry route, I think. But we'll talk through it. High school, I was actually homeschooled through high school. So I went to a very, very small high school, me and my older brother and my younger brother. And as such, I didn't actually have a lot of, you know, access to laboratories and computer science courses and advanced math that a lot of larger high schools would have. Um, and so I didn't really start with science or engineering until I got into college. I went to my community college down in Austin, down in Texas, and I took courses there just from all sorts of areas to try and decide what I wanted to do. At first, I thought, maybe I'll be a chemist, and then organic chemistry scared me, and maybe I'll do medicine, and maybe I'll do I don't know. And I took a computer science course at the community college. Finally, this must have been the spring of my sophomore year at community college. So all of my peers were getting ready to graduate with their 2-year degrees, and I was still trying to pick a major. And I took community college. I took computer science almost out of desperation of trying to find a major. And my older brother had gone into IT work, and so people kept saying, "Oh, you'd like computers. You'd be good with computers." So I gave it a shot and loved it almost instantly. Um, had never written code before, and dove into, trying to tweak and make the computer do and spit out new numbers and things. And was able to put into a transfer to the university there in Austin, the University of Texas at Austin, where I did my undergraduate degree and eventually stayed on to get my master's degree in computer science. So yeah, I got my transfer and I was in my freshman level computer science courses as a junior in college as a transfer student. Um, but it was good. I'd knocked out a bunch of basics in my community college and got to focus on major courses. So I went through that. I did some undergraduate research um, and eventually applied to the integrated master's program, which added a year to give me a master's degree, and did my research there on the Internet of Things and connected devices and security of those devices, which was really fun. I don't know anything about computer security, but I wrote a thesis in an adjacent field. And so I got introduced as a software security expert for a while. And then I joined the industry. I went to Microsoft, where I worked on the Windows operating system for a little bit, and the Azure cloud services for a while, for a total of almost 5 years. And that's what brought me up to Seattle. And then I was looking for a change and looking to take my software skills and apply them to the good of humanity and a way to kind of directly further things rather than a bottom line in a company. And that's where I found the Allen Institute. And I joined in 2019, just before I had 2 or 3 months of in the building before the pandemic hit. And at the Institute, I work on software systems for managing and computing statistics about all the data. So we have a bunch of the Allen Institute's, one of our core driving missions is open science, that we share all of our data so that people can either replicate our experiments or leverage our knowledge for further learning. And so my team builds software tools to try and share and visualize a lot of that data in web applications and through massive file downloads that other scientists can use, which is part of what my background here is. This is a view of cells in the human brain categorized by the transcriptomics data of the DNA inside of the cells. And for any scientists listening, there is a 90% chance I got that wrong. I'm getting thumbs up. All right, good. I'm an engineer, and I get the fun of kind of plugging into saying, like, how can I build something that these people who've done all sorts of science and education and experience can say, well, we have this problem, and something I would never otherwise understand. So it's kind of been a fun challenge for me to take my engineering skills and plug into a science laboratory.
Yeah. So, what does an average day look like for you, both now and pre-COVID?
Yeah, my responsibilities both before and after are the same. The big difference is where I sit while I do those. I'm here, I guess you can't see it behind me because of my virtual background, but I'm here just in my apartment. Um, but more or less responsibilities are the same. Whereas before I'd go in and on the bus and have meetings in person, now we have them all over Zoom as we are now. But an average day is, depending on where, we do an iterative cycle of hear feedback from the scientist on what they need, make some iterations on our tools, go and demo to the scientist and hear feedback and repeat. So it's anywhere from, listening to the requirements. Oh, we really need a tool that can visualize this new kind of mouse brain information. Working with my peers across a couple of software teams. So we'll sit down and break things out into, you build this chunk and I'll build this chunk, and here's how they'll fit together. A lot of time is spent typing into my terminal and trying things and testing and trying again. So a lot of one-on-one time with my computer, which is fun as an extrovert like I am. I get a lot of time typing into the computer one-on-one, and then we demo and get to show off what we've made and repeat.
So you are wrangling a huge amount of data. The statistic from fall 2020 is that the Allen Institute for Brain Science had, over the 17-ish year lifespan, collected 14 petabytes of data, which is 2.6 million DVDs worth, and you are responsible for wrangling that. What kind of challenges do you encounter being primarily an engineer to work with the scientists? Team approaches is really core to what we do at the Institute. So how does that team work?
Yeah, that's a great question. And yes, there's a lot of data. I think I'd heard a stat. I don't know how many DVDs Netflix has, but I'd heard at some point we have more data than Netflix has, which is a lot. I have done my best during the pandemic to get through all of Netflix, and I still can't. And we have even more than that. Yeah, it's an interesting challenge for me as a, like I said, my degrees say computer science in them. I have degrees of science, but neuroscience is very different than computer science. Fortunately, there's we have a pretty good, like you said, a good team approach to science at the Institute. And so there's a lot of, we get together, we talk, the scientists say, this is the kind of project that we're working on. This is our grant and our program we need to address. And there's a lot of time for questions. We have a couple of great project managers who are serving as really nice intermediaries for us that will go and listen to the scientist and come to us and listen to us and go back to the scientist, because I think there's a lot of, neither of us can understand sometimes. So there's a lot of good supporting personnel that are helping us kind of put the pieces together. I do a decent amount of reading also on neuroscience. My wife, after I'd worked at the Institute for a couple months, bought me this book, Your Brain Explained, and told me to read it so I would sound less uneducated in front of the science teams. And so I've done some of that stuff as well. But like I said, a lot of it is we have a really great project managers who kind of help us understand and whittle down so that I don't have to understand everything the scientists are doing, and they don't have to understand everything we're doing to collaborate well.
So what is your favorite thing about your job?
Boy, I think it's how cool it sounds when I say I work on brain science. That's not something I've gotten to say before. Um, that's less of a joke than I think I want it to be. But yeah, I think it really is the feeling of um, we are getting to have, as engineers, we're a relatively small team, certainly relative to my previous teams where I worked on Windows, which was a massive engineering organization. We're a relatively small team, and we get to have a pretty big impact
How big
on
is your team?
my immediate team. Is I work with two other engineers, um, and then we kind of collaborate with two other teams that are four people each. So even at, all up, there's, math, what is that? 11 people who are working. I promise I have a master's degree. It took me too long to do that simple addition. But yeah, so it's relatively small, coming from thousands to 11 people, but we get to have this outsized impact on science. And I've, heard former colleagues of mine from, or friends of mine saying, um, it was really nice. When I was leaving a previous organization, somebody pulled me aside and said, "My daughter has epilepsy, and you going and working on this is fantastic. The Institute is working with people who have epilepsy and trying to understand it better." And that's really special to get to have that kind of impact on people um, as a software engineer is really a unique opportunity.
So we have a couple of questions from the audience about finding meaning in your work at the Institute and making that transition from working in the software industry to applying your software skills to biomedical research. And can you talk more about the way you found meaning in your work now, how you found meaning in your work in the past, working in the software industry, and that transition?
Yeah, I think there's some similarities and some things that are really different. And I think the similarities are finding personal gratification in, the practice of engineering. As an engineer, my mind works, and I want to build things, and I want them to work well. And um, the pride of getting to show off, like, this is something this is something I created and I built with collaboration with the team. And that's really similar. I've had that across my career, getting the satisfaction of having a hard problem, sitting down and tackling it with a group of bright individuals, and then coming away with something that, fingers crossed, solves the problem in a way people can use. I think the difference is in the kind of impact I was talking about a second ago. So there's a different meaning of, working in industry is great. And we talk a lot in the software industry, a lot about the impact we can have and the reach of our impact. And I think a lot of times people mean that as the number of users that their application can have, or the number of installs of a piece of software, or the that kind of impact reach. And there is a lot of impact that's had that way. But it's been, after a little while, I found myself just kind of thinking like, oh, great, like, hundreds of thousands, millions, whatever, of users. After a while is, it's a number, and the number goes up and it goes down. And we're having an impact, but it's a business impact. It's an impact on a bottom line somewhere. Which is not to underscore that business is fine and making money is great. But there's something fundamentally different now to get to saying, like, okay, maybe we only have 1,000 monthly users or 10,000 monthly users of our web application, but these are now highly specialized scientists who are trying to solve some of the biggest problems we have. And just getting to hear about the programs where our scientists are going to Harborview and Seattle Children's, if I recall the correct hospitals in the area. And
Harborview in Swedish.
Harborview in Swedish. Okay, thanks. And those are great institutions who have people who are doing a lot to help, and us getting to work with them and collaborate to try and solve some problems that real people are facing is really nice. It's a really motivating factor, especially when you get to the times where it's like we're bogged down in our nth day of planning in a row, or this service isn't quite plugging in the way we thought it would to our overall architecture. Just getting to remember, like, okay, right, we're here to, try and help provide the building blocks that hopefully somebody will use to solve, or to understand Alzheimer's is, that gets me out of bed more than, we're going to grow our product by such and such percent. I think some of that is probably I lost an uncle to Alzheimer's not too long before making the switch. So I think there's a lot of personal motivation in there.
Yeah, it's approximately 1 in 3 people will develop a neurological condition at some point in their lifetime. It touches everyone.
And it's, I mean, just speaking for myself, it's kind of scary. Neurological conditions are, that's a lot of, core who we are, how we think, how we process, how you see reality. So, yeah, I think that was a big shift for me, was wanting to find something where I could contribute to the well-being of people.
So what do you wish more people understood about neuroscience research, about the role of software in neuroscience?
Yeah, a lot. I think to handle those in reverse order, about software and neuroscience, that it exists. As I would, prior to mid 2019, when I found the job posting, I would never have known that this was a possible career path for me. And so it's pretty great. I wish more people knew about this as an option, because, I don't have to retrain as doing all of the stuff we heard talk about, pipetting and in labs and titrating. And I took chemistry 1 and, well, I passed, we'll say that. And so I don't have to go and retrain to kind of get to apply myself here, which is great. I think about neuroscience and science in general is that there's so much we don't know, which sounds fundamental to say, but I was kind of surprised at the coming into science is the level of things we're trying to solve that we don't know about the human brain. So this thing behind me here is color coded at our best attempts to kind of categorize the cell types in the brain, because it turns out nobody quite can agree on what the types are of a cell in the brain. We know there are cells in the brain and we know we have neurons, but we don't quite know what the fundamental building blocks are and how they each interact. And that was a surprise for me. I thought, oh, well, like Jacqueline was saying, we've got drugs that we can take that, can help with certain things. So surely we understand everything in the brain. There's so many very fundamental questions that are still open. And so that was something that completely surprised me. It was like, oh, I thought we've laid down the basics of science and we're, going to push it as far as we can, but there are still questions that are very basic that we don't quite understand. And I think that's something that I didn't know, and I wish more people kind of understood. And because there's a lot of opportunity to dive in and help push those questions forward.
So despite our best efforts, sometimes science and computer science don't work the way we planned for them to. What has been your best science or computer science failure? Best learning experience, funniest, most surprising?
Yeah, I don't know what you're talking about. My code is always perfect. Yeah, so I was thinking about this question. You were kind enough to give me a heads up on this one, and so I had to whittle it down. I was like, oh, I could talk about this one or that one or this one or that one. I think my favorite one is when I was an undergraduate at UT Austin. I was an undergraduate researcher in the robotics lab at the university. And undergraduate researcher in this case was like a very, it's a generous term for, they let the undergrads hang out and try to like entice them to join the research programs after their bachelor's degrees. But it was great for me. Like I was, learning all sorts of stuff. And I was in the robotics lab. We had a self-driving car, an autonomous vehicle, which was awesome. And I got to, this was in 2000, 11 maybe. So, oh boy, I just realized how long ago that was. 10 years ago, which is well before Tesla autopilot and all of that. So that was super cool. And for us working as undergraduates, they didn't let us program the car for the obvious reasons. I at least didn't know what I was doing, but we had this robot that was based on a Segway. It was the wheels of a Segway with an extra third wheel to make it balance and some laptops and a camera. And my advisor said, hey, let's just make it, we'll do computer vision and locomotion. Let's make it fetch. It didn't have an arm, but we had this nice orange ball, and we'll toss the orange ball across the room and make the robot just go over and stop by it. And he goes, I'm going to go, it was a Saturday. The lab was mostly empty. He's like, I'm going to go have lunch and I've got to have another meeting and I'll be back in a little bit. And so I programmed this robot. I thought, I'll make it turn around till it sees something orange and then it'll speed after the orange thing and stop. So I don't know if anybody's familiar with the University of Texas at Austin. I'm wearing the color of the university. And so promptly I fire up the robot and I'm standing there proudly in the laboratory and I toss the ball and the robot turns and just goes flying off the other direction, speeding off towards the cubicles. And so I had to run after it and yank the emergency stop cord and the whole thing shuts down. So what I'd forgotten to take into account is there's orange everywhere, and somebody had recently earned their degree and had it sitting up against the side of their desk, which had a bunch of orange on it. The robot had not seen the ball, but had seen the much closer orange degree, and said, well, there it is. And accelerated. And I learned a couple of things from that is, one, let's, check our assumptions on what's in the environment. Two, maybe some safety checks are important, because my code also was like, while there's orange in front of me, accelerate more and more. So I got a nice sprint to catch the robot. But it was an interesting lesson for me. I mean, first of all, you learn, you tweak and you move on. But it's kind of something that stuck with me about, and how I view science and how we're talking about, like I talked about, we have Tesla autopilot and we have all these new self-driving cars. And there's all sorts of debates over, pedestrian, was a car in the right or wrong spot when a collision happened? Is the pedestrian in or out of the crosswalk? I think for me, the big lesson there was your environment's not always clean when you're writing robotics, and you need to write the robot to be able to handle that. Rather than, I could have said, let me hang up the degree higher where the robot won't see it. But instead we have to handle the complexity of the world, which is difficult, but also the right way to approach it. So it's kind of it gave me a heart attack. By the time my advisor got back, I got to go, oh, see, it all works just fine. Don't worry. Nobody almost died in here. But it was a great learning opportunity.
So what do you wish you had known when you were, say, heading into your early college experience about a career in the world of science?
Yeah, I think, kind of like I alluded at earlier, I wish that I knew that it was an option to me. Like I said, I was homeschooled, and so, which worked really well for me. But it meant I wasn't, I didn't have science teachers who were standing there saying, I am a scientist and so can you, or whatever the grammar is there. And, I'm a scientist, you can also be. And so it just never really struck me that I could go into, I never saw myself as a scientist. So I think that's a big thing I wish I would have thought more seriously about. Like I said, I fiddled with courses and took a couple things in community college, but it was never super serious until I kind of, like I said, I went through a route where I got into computer science mostly as, oh, hey, that's a degree and boy, they make money. So I guess I'll go do that. And, hey, I hope I like it, but either way, I'll have a job. And then kind of later discovered, oh, I can apply this to neuroscience. So I think had I known this track was there to begin with, I don't know, my path could look different. Maybe I'd be sitting here with, having done some sort of advanced degree in neuroscience or computational neuroscience. Computational biology could be really cool. And like Jacqueline said, we have computational scientists who do amazing work at the Institute. Yeah, so I think just recognizing that option would have been great.
And related to that, what do you recommend for students starting out on their computer science or engineering track regarding skills and classes that might be broadly useful?
Yeah, I think that there's just such broad fields in general. So I think um, general skills are great. Make sure that your mathematics are good, especially if you're looking to go through a formal education route. Um, the higher levels of education have more and more math. Um, Make sure your algebra and your trigonometry are on lockdown. Um, if you're like okay in algebra now, you're gonna find as you go on, it just builds and builds, and those basic fundamental skills for mathematics will contribute all the way through, especially a computer science and engineering degree, but most science degrees. I think as for courses, I would encourage you to look for, there's, of course, there'll be required courses that you should take, and those are all going to be algorithms and operating systems and kind of the fundamentals. But as you're taking your optional courses, I would look for professors who have reputation of getting hands-on in projects with students, or encouraging you to get hands-on in a project. Um, I find the practical experience is really, really great way to augment the theoretical. Um, there are certainly, theoretical tracks to science for sure. And if that applies, and if that appeals to you, run with it. Um, but for me, the more I had hands-on experience in, build this kind of project, that solidified my understanding of the theoretical, and, kind of cyclically made me think more about the theory, and then more projects. So I would recommend that. Get your basics fundamentals locked down, really focus on those. As easy as it is to say, I'm never going to use trigonometry in my real world, you actually might in these fields, and you certainly will use it in your upper level degrees.
And on the flip side, if you're majoring in a science, I would also recommend taking a computer science class. In particular, in the world of neuroscience, Python and R are the most common languages, but once you learn the skills, you can learn additional languages later as well. So much as you love doing the work that you do and it brings you a lot of meaning, you do not spend 24 hours a day at work. What do you do when you are outside of work?
Yeah, I'm a big soccer fan, which I'm pretty pumped. We're a couple weeks. The Austin FC has now started playing. The first time my hometown has ever had a pro club in any of the major sports in North America. So I'm excited. They'll be up here in Seattle playing the Sounders in a couple of weeks, so that'll be fun. And I play soccer. I'm a soccer referee, so I find a way to be nerdy even in sports. And I've got a little 15-pound Shih Tzu who I spoil to no end, so I take him to dog parks all the time. And that takes up more time than I should let it take, but dogs are pretty great. So
Never too much time for a dog.
yeah, exactly.
Do you have any final thoughts or recommendations for students who are considering careers in computer science or the crossover between computer science and the biological sciences?
Yeah. Boy, how much time do we have? I think, boy, that's a great question. I think I would encourage students who are starting in computer science in general, keep your mind open to where the path can go. A lot of times, the most obvious job paths are the industry path of, we can all name the giant companies that we use to search the internet and that make our phones, and et cetera, et cetera. But there are all sorts of great opportunities like the Allen Institute. That's it's a smaller team, so it's maybe not as readily obvious, but it's there if your mind is open to the new routes. So I would say keep your mind open. Think about the kind of impact you want to have in the world as you're going out and building things as an engineer or studying things as a scientist. And look for the opportunities to do that, and think about the kind of impact your software will have on people. We're seeing all sorts of cultural side effects of software now. There are great documentaries that have come out recently. One's Coded Bias about algorithmic bias and artificial intelligence, on called The Social Dilemma about the side effects of our ad-based economy of software. And so I think go watch those. They're both on Netflix and probably other places. Think about the kind of side effects and choose where you're working. Because while there are tons of things you can do with your career, it's really nice to, wake up in the morning and know you're making a difference, and in a real way in people's like health and their in their real life. So I think open mind, because like I said, I wish I'd known that there's this kind of crossover ability for software engineers. And I think a similar idea just applies to anybody looking for science and software together. There are tons of opportunities out there that for you to further the human cause. It just takes a little bit of looking.
All right, thank you so much. And those of you listening, you can learn more about the Allen Institute at alleninstitute.org. And you can find all of the data from the Allen Institute for Brain Science at brain-map.org, which is also linked from alleninstitute.org. So thank you everyone for joining us today. And thank you to Crystal for setting this up.